Hello, this is Earl, and I'm the owner of Custom Handrails and of the website customhandrails.com. I'd like to welcome you into my office today. I have a chair right back here. I'd like you to sit down and take a ride with me. We're going to be exploring the topic of mitered newel caps. When I first started doing these, I had a lot of situations that I didn't understand. And as the years have gone by and I've worked through some of these things, I'd like to share some of those things with you. So we're going to be looking at some photographs of some old stairs. We're going to be looking at some photographs of handrail that I have done. And we're going to be going into Rhinoceros, my drawing program. And we're going to see if we can put legs to some of these ideas and turn them loose and see what we can find out. So we're going to get on with it now, and I just want to thank you for watching. Okay, let's take a look at some nice old newel posts with mitered rail caps. This one, I like this one with the barrel that has the scallops and the detail as well as in the balusters. Nice turning detail. And this post looks rock solid here, and I have to say, for the most part, these old stairways, that was important because it may go up 2-3 floors with no newel posts at all. This may be the only one all the way until it reaches the end. So it was really critical to make these things look like the foundation, a strong foundation of the whole railing system. This is a nice, graceful easing into a large cap with a nice newel post. This one has a turnout in it, which makes the stairway much more inviting. It also allows a nice access if you're turning the corner and going back down the hallway. This is a rail cap that was on a job that we did some renovation work to some new rails that were done in the house. You notice it has this white button on the top. They call this a mortgage button. It was typically made out of ivory. Today, if you want to save the elephants, which I hope you do, we would turn this out of corian or something similar. This is a nice wide rail cap, 7.5 inches wide. It had a 3.5 inch wide handrail, bread loaf style. And you see the hole in the center there was for the rail bolt that was in the end of the piece of rail that was attached here. And you'll notice this decorative piece on the top. That serves a purpose. If you take a look at this next picture, you pop that cap off. It covers up all the attachments for this rail. Your holes for screwing this thing down into the newel post, the rectangular hole for when the rail bolt slipped in there, you see slid a nut down in the hole and threaded it on that bolt and snugged it up. So that was a nice way to cover up all the attachment points. Okay, let's go to some rails that I made recently. Mitered rail caps, and this is what the Rhinoceros drawings are based on. This size cap right here, this cap and rail, the same detail. And we're going to go through a few pictures of handrails that I've done with mitered rail caps on them. This is one that was in a tower stair, a nice sapele cap mitered in with a drop arm into the miter. Nice graceful transition. This is a Victorian style cap in red oak. You have a couple other views of it. Nice looking cap. And back to the sapele pieces again. Now you can see that I have 3 different types of mitered caps here. One with a straight section on, another with a drop turnout arm on it, and also an easing. And back to this photo. Let's go into Rhinoceros, and we're going to discuss how we can make this miter and this cap nice and clean, and most of all, matching the detail at the miter. That's the part that's difficult. So we're going to go into Rhinoceros now. This is a 3D rendering of that very cap that we just looked at. And what we're going to do in this portion of the video is show how to get this miter in the proper way. So here we go. Let's take a walk through this thing and see what we can figure out. Okay, you can see we have a 4 1/4 inch diameter cap, a 3 inch wide rail, and when we center this rail on the center of the cap, we need to extend the sides of the rail up until they intersect the outside diameter of the handrail cap. And then we're going to offset the diameter half the width of the rail, and that would be 1.5 inches. I've already offset that in, and that's where our miter is going to intersect and return back out again, so that the rail profile on half the rail appears to continue through the miter and around the cap. Now, when I first started making these, I thought that the cap would be the same profile as the rail, and I tried to do that a few times, and I was really disappointed that when I'd miter these rails into the cap, I just wasn't meeting up with the rail, and I really didn't know why. It seemed not to make any sense to me. So later on, I went and did some investigating with just some line drawings to see what my problem was, and that's what we're going to do right now. So let's come up here, and we're going to look at a way that we can transfer all the details of this rail onto the cap. So what we're going to do is we're going to act as though we're making this cap with the same detail as the rail itself. So let's turn on some lines here so we can see what we're doing here. We're going to project all the detail points, the end of the radius on both ends, the middle of the radius, and the same here, the end of the radius, middle of the radius, and project them up to the miter cut. We're going to do the same on this identical rail profile here so that we can transfer them over to the rail cap so we can rightly see where the details would spin around this cap. Now let's turn that on so we can see where those details coming from these points here would wrap around. Now if you take a closer look at this, you're going to see that if we choose 2 of these points here, this is where the intersection is. This is where the miter should be to match the details up. And you see that if we draw a straight line from one end to the other, we're not making it here. There's distortion involved. In fact, if we join these points up, we'll find that we have a curved miter that we're dealing with. And that's just not going to be too practical. So what do we do then? I want to make a cap now that matches the detail of the rail. I don't know how to get it. So I did a little research and found out some of the old school people had already laid down ways to find this out, and that's what we're going to do. I didn't discover this on my own. I found it out from people that really did know. So let's take a look at it. Let's turn a few lines on. We're going to do the same thing here again. We're going to transfer critical points up to the miter, wrap them, rotate them around to midpoint, and then vertically up. And we're going to do the same thing with this rail over here. We're going to do the same critical points on the same handrail profile, and we're going to project them across horizontally. And where that intersection is, that's where we're going to start drawing our profile for the cap. So let's do that here. Let's draw some lines here, project these up, same points over here, and where these intersect, we're going to want to put this radius in right here, connecting this point and this point and this point. So let's do that, and now we have the outside profile of this portion of the cap done properly to match the rail. So let's do the same thing with the next set of points. We're going to do the same thing. Turn that on. This would be the radius on the top, this radius here, and now we know that this particular line, if turned into a rail cap, will match at the miter point. And we'll do the same thing over again with more of the lines, and this one's got to go here. And as we get more and more of these lines, I've already drawn this in with some of these lines here. I didn't want to get it too confusing here. But this would be the method in which you would use to get all the points necessary to match up the detail at the miter. So you might say, well, how much different is it than the actual rail profile? Well, let's take a look and see. Let's take this rail profile and we're going to scoot it over here. Now I've mirrored this piece of handrail from one side to the other, so this is identical on this side. Now let's just see how we match up. I picked it up at the wrong spot. Let's try again. There we go. Alright, now you can see what your miter would look like if you had this being the actual rail miter and this being the line from the cap that you made improperly. You can see the difference here. It's let's measure that right now. We have about a 1/16 of an inch different. So somebody might pop up and say, well, what's the big deal? I just take some sandpaper and a chisel and we'll clean this up. Well, if you've ever done that, you know that it's not that easy. It would be much better time spent to actually find out how to turn this cap right so you didn't have that problem. So what we're going to do is go into this 3D mode and find out how I would do this today with the 3D drawing programs that are available today. So what we want to do is we want to extend this piece of rail, extrude it up all the way up to this 1.5" offset line, which is what I have done over here. Let me get rid of that. And once we do that, we want to take this in the miter box and trim this off to fit exactly over this miter cut here that we have in the plan view. And once that is done, then this profile that's on the edge of this is actually what we need to rotate around this cap, to revolve around this cap here and get our rail profile properly so that it matches. So let's take a look at that. We'll do that right now. Let's pick our outside profile, and we'll pick the top here to fill in that hole at the top. And we're going to revolve that around the center axis here. Okay, that was easy. Now this is what we want to produce. We have everything matching up right on the miter, and that's exactly what we want to achieve. So that's how I have come to figure out the problem and how to solve the problem that I was getting early on with the difficulty in getting the miter to line up here. I spent a lot of time trying to clean up stuff that really wasn't necessary until I really understood what was going on here. So that's the situation here. And this is the end result. This is what we're looking for. And we can turn that other drawing back on again and see this is the real thing here. And this was made from the drawing that we just looked at. And you can see this miter cut is nice and clean. There was hardly any touch-up and fiddling around with chisel and sandpaper to get this profile to match up. So that's what we are looking to do successfully, repeatedly, without a lot of horsing around. So the next problem that we end up having after we've gotten this cap turned, before we've cut the miter in, how are we going to cut this cap? Well, I'm not going to tell you right now. You're going to have to stay tuned and subscribe to my feed here, and the next time we get together, I'm going to show you a method that I've come up with that I believe works pretty well for cutting these caps. So there you have it. I hope you enjoyed the video, and it may have been a help to someone, and maybe just interesting to others. But there you go. And so until next time, stay safe and enjoy your work in the shop. Thanks for watching.